Here's a solution to practice quiz 8. I'm going to write up a key for you here. For point A, we're supposed to plot this polar point. We have to point in the direction 2 pi thirds. 2 pi thirds is sort of pointing that direction, and then we have to go -2 in that direction, which means we end up right back there, and I'll label it with an A. This, we have to point in the direction of 1 radian. Now, technically, I don't have to write this word radian. You're supposed to assume that if an angle doesn't have a unit, it's radians, but just to be clear, 1 radian, that's a little unusual. This is 0 radians. This is pi halves radians. That's about 1.5. So where is 1 radian? Well, 1 radian's about up like that, and I need to go out 3, so that's B. Remember, 2/3 of the way to 1.5 is 1, I guess. 270, that's all the way around to here, and I have a distance out, 1, 2, 3, 4, so that is C. Now, how about converting rectangular points to polar coordinates? Well, R should be fairly easy. R squared is this point squared. You could write the negative or not. When it's squared, it doesn't really matter. Plus this point squared, 4 squared or -4 squared. Now, I'm not supposed to round off, so I'm going to have to do this by hand. 4 times 4 is 16. √2 times √2 is 2. Plus 4 times 4 is 16. So what do I have? I have 32 there plus 16. That's 48. That means R is going to be the square root of 48. And if you wanted to, you could factor something out of that. I think that's 16 times 3, which you could reduce to 4√3 if you wanted to. Now, how am I going to get to the angle here? Well, the angle is tan inverse of y over x. So -4 over -4√2, right? And notice here that those negatives will cancel, the 4's will cancel. But this is going to give me, if I ask, hey, what angle is associated via tan inverse with a slope of 1 over √2, it's going to give me something in the first quadrant that has a positive slope, right? That is not what I want. My x value is negative, my y value is negative. That says I'm in the third quadrant, so I'm going to add pi to that. So when I'm asked for an exact value, my R is going to be 4√3. My theta is going to be tan inverse of 1 over √2 plus pi. Now, this is correct, but you might actually want to sort of get a sense of what that is. This isn't going to be one of your reference angles, but you might put an approximation in there just for yourself. That's not required for this answer. Okay, now we want to go the other direction. If I have R and theta, how do you get x? Well, x is R cosine theta. Y is R sine theta. -5 pi 6, well, I have a handy dandy circle up here, so you could think about -5 pi 6 as being right here, right? So what's the cosine of that? The cosine of -5 pi 6 is 10 times -√3 over 2, and the sine of that is -1/2. That's in the third quadrant, so you should expect them both to be negative. That gives me, let's see, -5√3 is my x-coordinate, -5 is my y-coordinate. So -5√3, -5 is that point in rectangular coordinates. Last but not least, how do I convert the rectangular equation, x squared plus y squared equals 3x, to an equation in polar coordinates? Well, polar coordinates, I'm going to have this piece equal to r squared. Remember, that's one of our sort of standard conversion equations. But then x you can always write as r cosine theta, right? That's actually what we used up there. So I can just use it right here. I can write this as 3r cosine theta, and there I'm set. That's my equation.